What are degrees of freedom in robot kinematics? Imagine trying to move a robot arm in just the right way to pick up a cup or assemble a tiny gadget. How does the robot know exactly how to position itself? That's where degrees of freedom come into play. Degrees of freedom in robot kinematics tell us how many independent ways a robot can move or be positioned in space. Think of it like the number of different directions or rotations the robot can perform without restrictions. It's a way to measure the robot's flexibility and capability. In three-dimensional space, a rigid body can move in 6 ways. It can slide along the X, Y, and Z axes, which are called translational movements. It can also rotate about those axes, which are rotational movements. So, in total, a body in space has 6 degrees of freedom. Now, a robot's joints determine its overall degrees of freedom. For example, a revolute joint allows rotation around one axis, giving it 1 degree of freedom. A prismatic joint allows linear movement along one axis, also providing 1 degree of freedom. Some joints, like cylindrical or universal joints, give 2 degrees of freedom, allowing more complex movements. Spherical joints are even more versatile, offering 3 degrees of freedom, letting the robot rotate in multiple directions. When you add up all the independent joints, the total degrees of freedom of the robot is the sum of each joint's degrees of freedom. For example, a robotic arm with 2 revolute joints and 2 prismatic joints, all working independently, would have 4 degrees of freedom. But in real-world robots, some joints might be linked or constrained, which reduces the total effective degrees of freedom. Understanding degrees of freedom is essential for designing control systems. Each degree of freedom corresponds to a control input, like a motor command or a sensor reading. Electrical engineers use this information to develop algorithms that tell the robot how to move precisely. They use forward kinematics equations to figure out where the robot's end effector will be based on joint positions. Conversely, inverse kinematics helps determine what joint movements are needed to reach a specific point or orientation. Most robotic arms used in factories or automation tasks have between 3 and 7 degrees of freedom. For example, a 6 degree of freedom robot can reach any position and orientation within its workspace, making it perfect for tasks like welding, assembly, or material handling. In simple terms, degrees of freedom tell us how many independent ways a robot can move. The more degrees of freedom, the more complex and versatile the robot's tasks can be. Electrical engineers relying on this concept to design control signals and processing systems that make robots move smoothly and accurately.